All right, welcome everyone to the August version of AI in Action. It's a little quieter over the summertime. Hopefully in September we're gonna have a full house. We, in fact, even events, Rush Mealy, I think we have like 15 events in September. So this is like the summer doldrums, and then in September they'll kick in. But it's their loss that they didn't attend our computer vision AI in Action. So this month's theme will be computer vision. And my co-host today will be Bryn Mark Conaway. Because he built one of the demos we're gonna see, and he spent a lot of time with computer vision. I said I helped. You helped build. Yeah, it's all a team effort. Reagan built it. Okay, great. Reagan doesn't like to be the spotlight, huh? Okay. All right, so we're going to talk about that. Kingsmen, a Spark company. For those that didn't hear, we have partnered up with Spark in Atlanta. I don't think there are any Spark people here today, so we can talk about them. No, we can't. But so far, we're only a month into our partnership with Spark, but so far so good. And so they're drawing a lot on our capabilities, and we're drawing a lot on their capabilities, which is exactly what we wanted in the first place, is to have that symbiosis of both organizations. So that's been really helpful so far. But you'll see a lot of our logos are now updated with a Spark company. All right, so when we talk about AI, there's lots of different definitions of AI, lots of different AI capabilities, and we've gone through a lot of these in our last AI in Action sessions, and today we're going to talk about computer vision, specifically image interpretation. So these other capabilities will probably tie in, but we're focusing on this, maybe sprinkle in a few of these other capabilities to come up with a full solution, but we're focusing on the computer vision for today. And we always want to talk about demos, not just pontificating. So that's the whole point of this session, the speaking series, is to actually see AI in action. This is our agenda. Bryn Mark will start off with the computer vision overview, just describing what it is, what it means, kind of set the context. And then I'll talk about crack detection in a brick wall. Then Bryn Mark will talk about how you can use computer vision to look at someone that's performing an athletic endeavor and give them coaching feedback and see how well they're doing. And then we've got a few, it's like the lightning round of some other computer vision stuff. So towards the end, we'll probably see like 5 or 10 different AI possibilities, but they're going to be quick and dirty. All right, you are up, Bryn Mark.
Right, thank you.
Want that? You want that?
I'll just use this one.
Okay.
Hey everybody, can you guys hear me okay? Cool. All right, so today I want to just cover the concepts of computer vision to start with. Obviously, computer vision is a field of AI that enables computers to interpret and make decisions based on visual data. So the key components of how computer vision works are image acquisition, so we capture images using some kind of device or data set. Process those images so that we can enhance and transform them or extract information from them. And then we also have feature extraction, where we'll take those images and identify important elements, whether it's edges, shapes, textures, the pieces that make up that image. And then we also have object recognition, so taking an image and being able to identify the different objects within it. There's several applications on this slide, but I'm going to talk about those in the next one. So starting with my first example here, we have self-driving cars is a place where we see computer vision applied. So obviously with the way that self-driving cars detect the world around them, they're having to take in real-time visual data, such as distance to cars, whether the light is green, red, yellow, whether there are pedestrians coming into the view. So here's where we're seeing one example. Also, we're looking at facial recognition. So beyond the type of facial recognition many of us are using to just unlock our phones or use Face ID for passwords, there's also facial tools being used for identification, along with tools for expression recognition, like the example I'm showing here, where it's able to detect live the changes in the facial expression. Looking at the medical applications, we have advancements in models that are trained on medical imaging. So whether we're looking at picking up fractures or measuring fractures in an X-ray, detecting tumors or other abnormalities in a CT scan or an MRI in a brain. Also with an ultrasound, sometimes, I don't know if many of you have seen an ultrasound, but it's hard to kind of determine anatomical structures. So some of our computer vision tools actually let you highlight those. Like we're seeing capillaries and veins in that top image. And then looking at surveillance and retail, I'm going to look at those together. Computer vision is being used to help improve security and monitoring in those industries, whether it's surveillance of a casino or your home or in a retail store. In addition to that, we see it used for loss prevention in the retail stores, but retail companies are also using these to analyze trends in store planning. They're being used for product placement, helping to identify ideal placement of products, and to helping automate inventory audits. Moving on to manufacturing, we see computer vision being used a lot in quality control. So this is obviously just a GIF example, but it's we're seeing where scans are used, and these image processors are looking at the things coming off of a production line and analyzing those for defects to help automate that process. And then something we'll cover a little bit more later, but here's just a couple examples of where we're using it in sports. So as that field of sports analytics continues to grow, we're starting to use vision tools to help improve whether it's strategy or measuring athletic performance. More and more, we're seeing them used to also do rule enforcement. I don't know if many of you have watched the Olympics that are going on right now, but like tennis and volleyball, they're using vision tools to help measure those lines to tell you whether it's inbounds, out of bounds, and help make those calls. And if you've seen any of those, the challenges from coaches and players, you'll see that they get that data pretty quickly, which is a cool one. So the last example I'm going to show deals with agriculture. So in this industry, we're seeing use of computer vision in several ways. So in the one example, they're using drones to help with plant identification, changes in crops to help see disease or other things within your crop. And then also in the livestock realm, you can see in this one where it's doing sheep counting, but you could see this example applied to not only sheep, but any of the other animals that you're dealing with on a farm. And both of these uses would also apply in like wildlife management or forestry. So a lot of times in a national park, for example, they're trying to track different animals throughout the park without tagging them. This is a good way they can do that with vision and track them. All right, so that's just a few overview examples of how we're using computer vision. I'm going to give a real quick high-level overview of how it works, kind of step by step. And this will relate to the demo that we're going to do later with our CoachAI. But basically, when we're thinking of a computer vision model, we're going to do image acquisition first. So that's where we're going to collect the image, whether it's from a camera or a sensor, or we could even have a data set that is pre-set up for us, whether it's a library of images or anything like that, that we're acquiring our images to send to our model. Then we're going to pre-process those, where we're going to enhance image quality, remove noise, adjust our contrast, resize, so that the images all will be interpreted a little more easily by the system. And then we're going to segment those. So in this case, we're going to divide images into different segments that'll help us simplify our analysis. And then we're going to move into feature extraction. That's where we describe important features within those segments. And then the last two steps here, we're going to go into classification. So this is where we use our machine learning models to help us classify objects or patterns within the image. And then finally, we're going to go to post-processing, where we refine those results and interpret the data. And so that's where you're starting to get data back. Looking at the technologies involved here, again, I don't want to go super deep into those, but we are looking at deep learning. So this is where we're utilizing our neural networks, helping to learn the patterns and features from a large data set. And then the convolutional neural networks, these are a type of neural network that are particularly effective for image analysis. So if you think of these like a human brain, the neural network will allow you to configure individual neurons so that we only receive certain parts of the input or the vector, which is the pixels of an image. And then instead of every one of those little neurons getting the whole image as input, it'll receive parts of the image, and then we create groups of neurons together that'll specialize at detecting certain parts or patterns of the image. And then with most of our machine learning models, we're looking at the algorithms. There's various algorithms that we'll use for different aspects, whether it's edge detection, pattern recognition, object tracking, any of those things. And now I will turn it over to Kevin.
I should have put a pause on that. Let me go back one. Can I ask you a question about that? So, with like you had the image of the store, where we let me go back just a little bit here. I think those Amazon stores, the Amazon Go stores, where you take something off the shelf and it registers that it puts into your account, into your bin or your shopping cart. But then it turned out not to be real. Do you remember that? No? So Amazon Go had stores like this where you could just grab stuff off the shelf. It was more of a convenience store, not a big grocery store, but you take stuff off the shelf, put it in your cart, and then just walk out because it knows your Amazon account number. And it looked too good to be true, and it turned out it actually was too good to be true because there were people in India that were monitoring the surveillances and actually like double checking that all the math was working correctly. So in that case, they were saying that AGI was really a guy in India, not artificial generative intelligence. So it was kind of a funny scenario that you think it was computer vision, but really it was just someone watching the video. Okay, now we get the music. I love this song. So every quarter or so, we give our teams a mission possible to go do. It's like a mini hackathon for a week. Take a break from their client work and go do something a little bit interesting. Exercise different parts of your brains and learn something new on AI. And so this was a team as Parker and Monica and Kevin Harding. Did I get those names right? Anyone else is involved in that? Just the three. Taki. I knew I was missing one. So what we asked them is, could you look at a brick wall or like stucco with cement, things along those lines, and look for cracks? We were talking with Lucid Drones in Charlotte, and we said, hey, you know, what else do you do with your drones? You look at buildings all day long. What could you do with it? And like, well, if we're looking at buildings all day long, we could look for cracks in a brick building or cracks in a water tower or things along those lines. Like, well, let's play around with it. So we made it one of our hackathons, one of our mission possibles. And we said, okay, could you look at two different photographs and identify a crack or a repair? And then the second one is, could you just look at a surface and say, that's a crack? All right, so those are the two different ways we're going to look at it. And so let's go with the two sets of photographs at first, and there's going to be a little bit of audience participation here. So we start off with this. Like, the brick might be a little bit complicated. Let's use this as an example. You see this like in Reader's Digest or something like that, where you've got one picture on the left and a different picture on the right, and can you spot the differences here? So I'll give one example, and I want to hear some audience participation here. So I can see that there are two pieces of sushi on this side of the chopsticks, and over here there are three pieces of sushi. See any other differences? John? Yeah, the sesame seeds are missing there, right? Who else? Davina? The green, this here? And versus yellow? Yep. Good eye. The piece on the bottom? This one here? Yeah? Okay. Oh, the salmon's missing? There's no salmon here, but it added there? Yeah? a carrot. Oh, you are missing. Oh, yeah, sure. I'm not even sure that we caught that one. So using a vision model, oh, you're right. We got that carrot, or whatever, yeah, I guess it's carrot, and the sushi. We talked about the sesame seeds. This one's missing. That one's added. And then this one was a tough one we didn't even spot. See how there's marbling in the salmon up there? There's a little bit of marbling that's missing. It's kind of faint, though, but it's there. So like, okay, that's a good exercise. That's a good way to start off. And then we started looking at some pictures on the internet of brick walls. And this is an example where a brick wall was broken. There's a crack on it. And then here is repaired. And you can kind of see how like there's an extra brick in there because of different coloring. So you can see it was fixed. And we started looking at that going, well, we can't just compare these two images because they were taken on different days with different angles and different shading. And so we had to kind of normalize them. That's the first step before we can kind of compare them. You see how we get the whole brick going all the way down, very, very linear. It's square, where this is angled. You can see there's a lot more sun in that photo and more shade in this photo. So we have to normalize all that to make sure it'll work. So our Denise Beachley graciously donated her house. She was hanging an outdoor TV on her deck. And since she was doing it anyway, she gave us a before and after photo. So this is before she started drilling the holes, and then after she drilled the holes. And she took pretty good photos of it, and it wasn't that far apart. It wasn't like days or years apart. It was just probably an hour apart. But you can still see how this is, this angle of the mortar is up here, and that the mortar is down a little bit lower. You can see that it's just turned a little bit, and so we had to normalize it first. And this is a GIF that kind of goes the before and after, so you can see it's off a little bit, right? It shifts up and down. So we have to normalize those two photos. And so you do that by saying, well, in this photo, this point over there matches that point over there. And you figure all that stuff out, and then you start doing the shading. And now this was the before picture before we did any modifications, and then here is the before picture after we did the modifications. So it's adjusted. You see on the top there's the black spot there, right? So we shifted the picture down a little bit, so now they match a little bit better. And then we took those two images on top of each other and compared pixel by pixel. Think of like two images in front and back of each other, and you see where the pixels are a little bit different. And so you can see where the holes are. There's a lot of pixels that are different, but there's some other pixels that are different along the way as well. Just angle of the light and things along those lines. And so then what you do is you dilate those differences, and then you set a threshold to say, I only want if there's a difference that's big enough, and those dilations start to connect to each other, and then that's too far. Right? So we really want those 4 spots because all these pixels are connected to each other, so that's probably a difference. And so the end result of that was this. So you can see where the differences are that were highlighted, and while there's the hole, that's an obvious change. I guess this is where you marked it, right, Denise? The white piece is where you marked it? But there's this spot here and this spot here, which I'm guessing is dust from the drill. Yeah. So as you drill through the masonry, you get some dust coming down, and identified that as well. So that's one example of taking 2 photos and trying to compare them. So imagine that you are, if you're Lucid Drones and you are you're power washing a building, a 6-story building, and then next year you power wash the same building, you might want to see whether a crack has changed from the first time you went and did it. And then the other part of the mission possible was, can we just look at one photo and see whether or not there's a crack in the image? And so what the team did is they went to Hugging Face and grabbed a vision model, and they trained it. I think there were 100 or 1,000. Does someone know how many they did? 100 or 1,000 images? Maybe it was just 100. But they put in 100 images that did not have a crack and 100 images that did have a crack, and they explained these have cracks, these don't. And so using this YOLO V8 and then submitting this image, just crack2.jpg, they're able to, with 95% accuracy, determine that that is a crack. So it worked pretty well. Now the question is, can you do this with video, right? So we're looking at one still image, but if you're a drone and you're panning across a building, across the entire building, could you take all those video and break it down into all these different images and compare each image? So that's definitely more than you would do in a week-long hackathon, but we've proven that concept was working pretty well. All right, Brendan, Mark, go coach us.
All right, thank you. Am I still on here? All right. So, like we mentioned earlier, so this is an application that we started. We created with the same sort of hackathon. We made a Coach Vision app that we now have titled CoachAI. And our team here at Kingsmen put together a nice little UI for us that I'm going to shift over to. So I know Kevin gave a little preview of our Kai demo site last week that we're using in-house for some of these demonstrations. And within that, we have our CoachAI application. So kind of like I talked about earlier with the concepts of taking an image and evaluating it, we're doing something very similar here with videos, where we're breaking them down, analyzing the frames of that video. So every video is made up of a series of frames, which are still images that make up the video. And so here we're doing that with different sports videos. So I'm going to do one live demo here, and while that's processing, I'm going to show you a couple other things. So I'm going to choose this video that I have, and we're just going to upload that here and have it analyze, or maybe we won't. All right, that one might be too big. So we'll go to the prepared one. So that's why we, as Kevin says, take the turkey out of the oven. So this is one that we sent off to our single model. We're using Gemini 1.5 Pro here to analyze this video. And so this is a recent video of Simone Biles in the all-around team competition at the Paris Olympics. And I'll just play this for you. It's only 38 seconds of how we analyze the video, and then get a voiceover put on top of the original video and get our coaching out of it.
It's clear you possess incredible talent and dedication to gymnastics. Let's take a look at your floor and vault routines. Your fluidity and control are impressive, especially on those complex skills. While your leaps on floor are high, imagine pulling your core in even tighter on landings for increased stability. On vault, that powerful run is fantastic. Try experimenting with a higher block during your hurdle step, keeping those arms straight to maximize your height off the table. Remember, even the smallest adjustments can make a big difference. Keep pushing yourself, and your scores will reflect your hard work.
All right, so we've given this a prompt under the hood to help it give the feedback based on what it's seeing in the video. And we tell it to be a pretty positive and give corrections no matter the skill level that it sees. So as you can see, this is best gymnast in the world, arguably, and it's still giving her pointers on how to make simple adjustments to improve. So I didn't really get to talk about a lot of this with the first slide that I meant to. So what's happening is we're giving it a full video, and it's taking and analyzing a series of the frames of that video. And then within that, we're getting descriptions of the video, descriptions of what a coach would be based on the sport that it sees in the video. And then we're getting all of that information. We're summarizing it into a script for a voiceover. And then we're taking that script, sending it to a text-to-speech model, and then we're getting the voiceover, which we then stitch back on top of the original video. So I'm going to show a few other examples here. So another popular sport, obviously, that people like to analyze and get corrections on would be anybody in here that golfs. I'm sure at one time or another you've set up your camera, recorded your golf swing. Now, obviously, this is another one of the greatest golfers around, Dustin Johnson, or used to be at one time or another. And so here we're comparing models. So this portion of our application allows us to take one of these 8 models that we have listed here. So our 4 Claude models, 2 Gemini models, or 2 GPT models from OpenAI. And we can set those side by side and compare them. I won't show you the full videos of each, but we can see here that we're able to get the same type of voiceover, but they might be a little different based on how those models.
Swing demonstrates excellent fundamentals and professional level technique. The fluid motion and balanced follow-through are particularly impressive. To further refine your swing, focus on maintaining a more consistent spine angle throughout and
So that one, again, it's given a PGA Tour golfer corrections, which is good because we want it to be able to coach and not just say, you're the greatest. We want it to be...
In this video, we observe a golf swing, specifically a full iron shot. Your posture is excellent, with a solid athletic stance and good weight distribution. The shoulder turn and hip rotation during the backswing are impressive, generating significant power.
So again, here you're seeing where it's actually looking in that video and seeing his, hip rotation, his upper body torso rotation, and the iron swing. So it's able to pick some of those details out of the video and then give us that back as our voiceover. So what I want to show here is...
Mark, did you find that some models were better than others? Like, do you ever find a preference?
Yeah, I think we do. We see that, especially the newer models, obviously, are going to be a little bit better. But I think our Gemini 1.5 Pro, GPT 4.0, and recently Claude 3.5 Sonnet that's come out, those are probably the best 3 models that are pretty comparable. Personally, I feel like you get better outputs from 3.5 Sonnet, and I like the fact that my voiceovers generally match the length of the original video. So a lot of times you'll get some where you'll have a voiceover generated that's much longer than the original video, and that's just the way that the LLMs are being a little more verbose with the way that they're building that script for us.
How many stills are you passing in per video? Repeat the question.
I want to say we take about every 20 frames is what we're doing. So depending on the length of the video, I want to say maybe about a minute-long video, you might find 900 frames. And so we're taking every 20th one to send to the model, to the vision model.
How do you deal with limitations on how many certain models have limitations like size or 20?
Yeah, I think
Can you repeat the question?
Okay. So the question was, how do we deal with some of the models that have limitations on the frame count? And I think we tried to get it to the minimum that we could do across all the models so that they all would be within the proper range. So it was a good question. We originally, when we first started, we were sending it like every other frame. And we found that was too much. Like there was just too much data that you're sending off. The processing times were like ungodly. So it's that's why we started playing with how many frames we could send. Yep. So.
Read a question? Here.
Yeah.
All right, sounds good. Hey, and apologies if you mentioned this, but is there a RAG component to this?
No, there's not in this model, not in this demo.
In the prompt, did you have to call out kinesiology specifically or tell it to go read some books, or did you
No,
do
and
any?
I actually can cover that right now with the next thing I'll show here. So
Thank you.
with the video description in this first tab, actually it's highlighting the wrong tab for me. So in this tab, this is where we're looking at the description of the video. So this is where we've sent those frames off, and now as the way we've prompted the models is the same, but we're getting different outputs. You can see here the way that each one is interpreting. Sonnet 3.5 is a little shorter. It's a smaller, it kind of gives you more concise answers to help read what is in that video. So you can see, just looking at this as an example, it's identifying that the golfer maintains an athletic stance. It's pulling out the details of that swing. We look at the skill level. So you can see, we know that was a professional golfer, exhibits a high skill level. So it's pulling that all out and creating our video description. And then based on this video description, we have a second prompt that says, okay, now you know what this video is about, you know what the sport is, describe the job qualifications for a top-level coach. And so it's just a prompt that we're giving that video description within, and then it's giving us the job qualifications for that coach. So I think this one, the 4.0 model in this regard, was giving us the pointers that a coach would give. So you see, like, staying balanced on follow-through techniques, or being fluid and controlled on your movements. Those are the things a coach would say. Versus this one, we're getting the job qualifications, right? Where we're seeing proven track record of coaching at a high level, or ability to convey complex concepts clearly, which are the qualifications of being a professional athlete coach of a professional athlete. I'm not sure if that completely answered your question, but it's basically, we're just using the LLM's knowledge of a sport to give us the job qualifications, how it understands them.
It's surprising.
All right, so I got a couple more examples for you guys that, so based on those, actually, to take it one step forward, so on another, maybe a next iteration of this project or an enhancement to it would be, okay, I have all these different words on the screen, is there a way that we can get similarities of the different models? So one thing we've played around with would be, I've taken those descriptions here, just fed them into ChatGPT, and asked it to, at the top you can see, summarize them and explain similarities and differences. So this could be just a concept to build on, would be that we're getting, summaries of the two videos, and then getting similarities of maybe comparing the two coaches to help us find out which coach was better. That was just an aside. I wanted to show that. I thought it was a cool thing we could think about doing. Next, what I want to do is I want to show how it handles sports that are odd, things that are maybe not the norm. So in this one, I'll play one of the two videos. I did Sonnet last time. Let's do 4.0 this time. So this is bowling ball soccer, and I'll
In
blow
the
this
video,
up.
we see two activities: bowling ball soccer on an ice rink and a weighted squat in a gym. For the ice rink activity, your low posture is good for balance, but frequent falls suggest a need for better weight distribution. Consider wearing shoes with better grip and practicing balance exercises off the ice. In the gym, your squat form is solid, but visible strain indicates the weight might be too heavy. Focus on proper breathing techniques and consider reducing the weight slightly. Great effort in both activities. Keep practicing and you'll see improvement.
So obviously, we need to keep practicing in the gym.
I'd hate to do headers in bowling ball soccer.
I don't think you would survive that. So the thing I did like to show on this example was, originally I didn't realize at the end of this clip there was also a weightlifting scene, but it was able to pull both of those different activities out and give me coaching pointers on them separately. So it started with all of our bowling ball soccer, which, any volunteers want to play out in the courtyard? And then at the end, obviously, it saw that we're doing weightlifting as well, so it gave us coaching pointers there. And then the last one I wanted to show here is, what if I uploaded something that wasn't a sport at all? And so this one's fun to watch, so I'll let you guys watch it as well. But I gave it a video of a YouTuber making a tiny Big Mac, and let's see how it handled that.
In this video, we see an impressive display of miniature culinary performance art. Your precision and control in handling tiny ingredients and tools are remarkable. The way you manipulate the miniature stove and cooking implements shows great familiarity with your equipment. Your movements are generally fluid, especially when assembling the tiny components of the miniature burger. To enhance your performance, consider maintaining a more consistent eye level with the work surface. This will improve visibility and reduce strain during extended sessions. Also, try organizing your tools and ingredients more systematically for smoother transitions between steps. This could lead to an even more polished presentation. To take your art to the next level, experiment with incorporating more varied techniques to showcase your versatility. Consider adding narrative elements to further engage your audience. You could explain the process or share interesting facts about the dish you're creating in miniature. Your enthusiasm and skill are evident, and it's clear you have a passion for this unique art form.
So I'll stop it there. So the thing I liked about this is it's able to recognize a few different things. So it's coaching him, it's giving us coaching pointers on not only the skill of tiny up-close cooking, but at the end there, you kind of hear it telling him like how to be a better YouTube presenter almost, right? So it's like giving him advice on how to engage with his audience. So that's where, while we call it CoachAI and we relate that to sport, there might be other realms where we could see use here with getting coaching feedback. And even if you think about, I guess if you want to think of more of a business case here, if we think about maybe looking at ergonomics in a workplace, you could have somebody get a video of how they sit at a desk and then get coaching pointers on that, just as an example of something else we could look at.
I'm looking forward to putting this video right here, through CoachAI to give us tips on presenting.
That would be interesting. All right, that's all I have for CoachAI. Any questions before I move on to my next brief demo? Awesome. So without going back to the PowerPoint slide, I'm going to stay in this browser, but we're going to move into our honorable mentions category with some other cool things using vision that we want to show to you guys today. So we talk a lot about reading documents and seeing things with our LLMs. In this example here, I'm going to give ChatGPT an image of a research article about ACL prevention in athletes and ask it just, what can you tell me about it? So just to be clear, I know you guys can't see that, and I'll try to blow it up so you can see the original as well, this is just a picture screenshot of an article that I'm going to just attach to this ChatGPT. And let's hope this works like it normally does. So you can see here, it's looking at that image and giving me all the key points from the article, including the different clinicians that worked on it, that it's a consensus statement, all of these different things. But then if I show you this, you can see it has all of these different researchers that worked on this and the primary authors. So in particular, I used this one because this was a study from when I was in grad school, and I helped participate in this study. So I know that Sandra Schultz and Randy Schmitz are two of the main researchers, and I just want to see if it's actually reading that. And I'm going to ask it, who are the authors? Maybe I can type. And so you see here, it's just from that image I gave it, it's able to pull out that list of researchers that we saw on the article. So I just thought this was a cool example of how the LLMs are kind of catching up using different vision elements and able to interpret things on the fly. The next one, I'm going to switch over to Claude, where we're going to use some of their smart artifacts here. I know we did a brief view of these last week. Again, I'm giving this an article. This one is about the Hoffman reflex and applications for how we use that in sports. And And without getting into too much of that, it's just talking about a reflex of how we use electrical stimulation to simulate muscle spasms and reflexes. So here it did the same thing. It took that article. It's given me information about the authors, the publication details, things like that. And then I'm going to ask it to use an artifact to explain the H reflex. And so we can see here, it's using this artifact after just taking that image screenshot of an article that I uploaded. I've asked it 2 questions. I got a summary of the article, and now it's giving me a nice workflow of how the H reflex works. And it's just right there as an artifact. So this is kind of just an example that I thought was cool, where we are using some vision component to read an image and then interpret that, analyze it, and give us some additional information and diagrams around it. And after that, that's all I got. Any questions for me?
David's got one. Is there a microphone up there?
2 microphones up here.
Nothing but the best.
Yeah, so Bryn Mark, the 2 examples you just showed, I'm assuming those were multi-page articles, research articles.
The actual articles are, what I provided it was just an image of part of the article.
Yeah. Did it go and find the original, or did it just read what you uploaded as a screenshot? Were you able to tell?
That's a great question. So in this exact example here, it's hard to tell.
Okay.
And without me going in, actually, I don't probably know enough about that research article
Sure.
to tell you the ins and outs of it. But my guess would be it would do a pretty darn good job. And if it doesn't know it, it would try to look for it.
Yeah. Okay, cool, thanks.
All right. Any other questions?
I want to point out that Asif was talking, we were talking about this earlier about when you have a PDF and the PDF is a lot of text, you could just submit the PDF, like you do a parser and get the text out. But if you were looking at like a catalog you were talking about, if you have a catalog with photos and images and text descriptions and things along those lines, you would probably want to take that PDF and send it as an image, which is exactly what you did. Yeah. Nate?
Could you maybe speak to, like, did you have any issues with hallucinations, and in what way did you see it hallucinating, or various models?
At least in this example, I didn't, because I knew to ask specific questions about it. But I'd imagine that with any LLM, you're still running the risk that you might be. So as always, maybe validate your findings of what you're getting. But I don't think I've seen a ton of that with this example. But that is a great thing we could probably explore further.
Did you have a question? No?
All right.
Patty? No? Okay. I thought I saw your hand go up. All right. Thank you.
Back to Kevin.
Back to me. Are we back in the PowerPoint? We are. So we did Claude, we did OpenAI. So now the speed round here, these 4 things: creating screens from whiteboard drawing. We saw that last time, but we're going to reiterate it just because it's a use case for computer vision. Bag sizes at stadiums, using AR, augmented reality, on a construction site, and then using AI glasses. So we saw this last time. I had my whiteboard here. Where's my prop? But I drew this on a whiteboard and I took a picture of it on my phone and I put it into this TL draw. And I said, make it real, and it turned it into a screen. And then that screen is actually a usable screen. And it gave me the HTML code as well. And so clearly just an image that it turned into code, which in functioning code as well. So that was pretty neat. This is something that our Spark colleagues have worked on. And so a very recognizable sports team was looking to speed the entry into their stadium. So you have to use a transparent bag if you're carrying a bag in the stadium, and it has to be measured correctly. And right now the the attendants that are, when you're walking through, they're basically measuring the bag with either a ruler or with a stick or with some sort of a container. You know how like in the suitcase container when you have at the airport where if you can stick your suitcase in the container, then it's fine. But they want to give their agents an app that could just go use computer vision and identify whether the bag meets the requirements or not. This is a company that I actually called me. We have a common friend. They're in Portland, Oregon, but they use AR in order to do a construction site. So imagine this building, not the building, but our facility in the building that was being built, when they're putting in the electrical and the HVAC and the fire suppression and all this good stuff. All those architectural drawings are in some sort of computer somewhere, but imagine putting on AR goggles and walking around and seeing all those models layered onto your reality. So you can choose what layers you want to include or not. You set your axis, kind of an anchor point, and then you can walk around and see where the HVAC might be, where the electrical will be, where the sprinklers are going to be, and you can look up and look down and walk through it. It's pretty neat stuff. And I think the current feedback is it'd be much better if you have an iPad, just because you walk around with goggles all the time is a little complicated. But you might run into things. But they have an iPad version now. But that seems like really forward thinking. Can I do that on post-construction? That was Ken's question. Can you do it on post-construction? The answer is yes. In fact, she was telling me, Marette, her name is Marette, that a particle collider is using it for maintenance because it's so damn complicated that they can take what was actually built, and then as you're looking at different pipes and whatnot, you know what that pipe does. Yeah, after the fact. Who's using it? Game of Thrones? Here, David, I'm going to give you the microphone.
So what they're doing at like Game of Thrones is that for the special effects, for the actors to know what's going to happen, they put the actor on the dragon in the green room or blue room, but they show them in advance what the scene around them is going to look like. So it's like partially built. So an actor knows, okay, I'm going to start at the top. There's going to be a cloud. I'm going to come through the cloud with the dragon. I'm going to descend down. There's going to be a person on a horse running there so I can like interact with it. And then it's coming back up. And so they can see and visualize the entire scene when nothing is built in the room. So they know what's going to happen and act accordingly to that. It was in one of the special shows.
Nice. All right, so this next one here is Ray-Bans and Meta combined or co-branded some glasses. You may remember Google Glass from several years ago. It was kind of hokey because it like kind of stuck in front of your eye, and people looked weird when they were doing it, and it wasn't extraordinarily valuable. But this is, it's been out since for a couple of months, and it's just $300. I was going to get a pair, but then I also remember my birthday is next week. So if any family members are in the audience, just saying. But what it does is it takes regular wayfarers, right? You can see that these are not dorky glasses. This is regular Ray-Bans, Wayfarer type glasses. And it puts cameras in it. In fact, on either temple, one camera is a video camera, one camera is a camera. I think I said that right. Stills, thank you. And then, so you wear them, and then you can use the capture button to take a photo. And then you have speakers that are in your, not in your ear, but on your ear. So you can still interact with people around you. And then there's also the microphone to listen to you. So and then there's an LLM. It uses Meta's Llama model in the background. And so it is using an LLM underneath. Go back to that first capability slide. It's using an LLM underneath. It's using speech to text for me to interact with the LLM, and then that's text to speech back so it can talk to me. And then it's also using the computer vision to see what you're looking at. And so I have a little video here to explain how all that works. It's the influencer.
These sunglasses from Ray-Ban and Meta can now answer questions about what I'm seeing, which is wild. So I took them around New York City to see what they can do.
Hey Meta, look and tell me, what's the history of that monument?
It was built to commemorate the centennial of George Washington's inauguration as president.
Hey Meta, look and tell me which of these fruits would make a good smoothie.
Oranges, apples, and kiwis. These fruits would make a delicious smoothie when blended together.
Hey Meta, look and tell me, what church is that?
The name of this building is Washington Square Methodist Episcopal Church.
This is so wild. They're doing all of this with Meta AI. When I say look, it's taking a picture, analyzing it, and then using a large language model to give me an answer.
When it's recording, the light's on right here, which means I can get shots like this.
And photos like this. I really like this one.
Like, look at this. I'm recording without using my hands. It's all coming from right here.
And it can even use AI to make my shots better. And one of the newest updates is that I could video call someone to show them what I'm seeing. For me, what's really exciting about these isn't just that they let us film and capture our lives in a new way. It's that they let us ask questions and be more curious and get answers and interact with things. And it's fun. That's what I like the best. If you like optimistic science and tech stories, follow for more.
Anyway, pretty neat. And so the one thing it doesn't have that Google Glass had is a visual representation, right? Yeah, Stephen, you get it, right? There's no visual representation. Now, in one of Google's announcements a couple of months ago, while they were demoing stuff, they had something look like this, but it was Google, not Meta. And it kind of gave a little Easter egg of the person was watching something in their glasses. So there's a hint that Google is going to be coming out with that soon, just a little display. And now the question is, if you've got an LLM talking in your ear, you're talking with the LLM, and there's a little display, and there's computer vision going on with your eyeglasses, what could you put all those things together to do? And one example, you guys may have heard of Zinnia here in Charlotte with Lauren, and she's been talking about, can we go to a conference where you've registered everyone's face, and so you're walking through this conference, sorry for the very fast-moving GIF here, but you could walk up to someone and you see their face and it just analyzes their face and brings up their little bio and says, oh, this is Ken, and Ken does this, and this is Ken's favorite food, or this is where Ken went to school. And so now all of a sudden you'll go, hey, Ken, yeah, good to see you. How's the car racing going? And so you can have much more personal interaction with that. And then we're talking with a cruise line and saying, well, maybe you could rent these glasses to the people that are on your cruise line for $50 or $100 for that session, for that week that they're there on the cruise. Because the first thing you do is when you got one of these gigantic cruise ships is you spend a couple days trying to figure out where am I and where am I going to. And so if you're, let's say, where's the theater? Like, oh, there's 8 theaters. Where's the theater that I'm currently registered to see the movie or see the show at 7 o'clock? And how do I get there? And so it can navigate you through the ship. And you could have those glasses on as you're walking through the ship. Hey, what's that store over there? What does that store sell? What are the hours of that store? Here's a theater I want to sign up for a show at 8 o'clock. And so you can interact with things a whole lot differently by combining all these capabilities together. All of a sudden, the art of the possible starts changing. And these are just a couple examples off the top of our head. I'm sure there's hundreds of thousands of them. So I think that's the next wearable. I've not gotten a watch because I don't need to look down and look at all of my notifications. I get enough emails. But I think wearing the wearables is going to be a lot more fun. Here's my prop. Because I can just see those things coming up all the time, and I don't even have to divert my attention to look down at my watch. How are we doing on time, in fact? We're at 7 o'clock. Good job. All right, next AI in action is this 5 weeks from now? I think it's 5 weeks, right? So first Thursday of every month, September 5th, it's that week of Labor Day. So you've got Monday off, and then come Thursday. We don't have a topic set yet, but we'll try to keep the same sort of theme where we have one consistent topic. I'm guessing maybe document ingestion because we have a couple of demos lined up for that. And that's all we have. Any other questions? like the music. All right, any questions? All right, let's go grab a beer. Thank you.